Hello, this is a course Getting Hand Dirty with Assembly Language. Assalamu alaikum. My name is Muhammad Khizar Bajwa, and you can contact me. You can contact me on this email khizar.bajwa107 at the rate of gmail.com, and you can contact me on my phone number.
So what's up guys, in this lecture we are going to study about arrays and different other things. We will get an array of 5 elements and we will add all of its elements one by one. So let's get started. I will write the first I will write down the code, then I will explain each and everything one by one. So as I have written my code, so I am now going to start discussing each and every step. So org 100h means we are going to start our program from memory location of 100h. Then we have a data segment dot data, in which we will declare our variables and array. As I have declared my array as Hither, and db stand for defined byte, which is a data type, and we are using hexadecimal number. If you want to learn assembly language, then you should know binary and hexadecimal numbers and their mathematical operations. Then I have and one more variable, which is sum. I have declared its data type to be byte and initialize it with 0. Then we have a code segment. In code segment we have a main procedure. As we see in Java, in C we have function, and in Java we have method. So in this we have procedure, the main procedure. Then we cannot shift this segment to dx, which is a data segment, data register. So we will shift this data segment to dx indirectly. We will first we will shift dot data to ax, then we will shift ax value to dx. So this ax is destination and this is source, and here in this instruction dx is our destination and ax is source. Then I have initialized ax with 0 and move cx comma 5. Move cx comma 05, which will load the value 05 into the cx register. This register is used by the program as a counter for iterations or loops. Then we have an instruction move bx offset feather, which means it will load into bx the offset address assigned to the data. The assembler start at the offset 0000 and use memory for the data, and then assign the next available offset memory for the sum, in this case 0005. So in simple words, we are shifting the offset address of our array to bx, which is a base index register, a pointer which will be used for pointing to each and every element to access these elements. So this line means that. Then we have a label again, which will be used for our loop instruction. As I told you in the previous lecture, there is a two kind of labels, data label and a label that we use for control instructions. This label is control for use for control instructions, and this figure and sum is a data label. Then moving on, we have add al. As I told you, on the left side we have our destination, on the right side we have our source. So we are shifting bx value. Bx, this is a these big brackets told our assembler that on this address get the value, which is a 25h, and shift them, add it to al. So our first value will be added to al. Then we are incrementing our bx, which will, after increment, it will point to 12h. Then we are decrementing our counter, which we are using for loop cx. We are decrementing it by 1 and incrementing our bx by 1. Then we have j and z, means jump not 0. If our counter is not 0, then it will jump to again till our value becomes the value of cx becomes 0, which is we are decrementing by this instruction. Then after summing all of these elements, we are moving al value to our variable sum, and we want to print on the screen. For that we have a function move a high comma to h. These two lines is a single function which will call our console window to show the result, and it will show the result which will the value of DL, which we initialize with our variable sum. So whatever the value of DL, it will show on the console. So we after that we have an instruction move a high comma 4ch and interrupt 21ch 21h. These two lines will tell the will return the control to our operating system, and at the end we have np end procedure main, which we will have start with the uh, main proc main procedure, and we will end it with the same identifier which we have started with as a main is the identifier here. So np main, then we have a instruction ret, which will mean return the control to the os operating system. So I am going to emulate it, run it. The value here appears to be a different kind of character, but we will expect to get some values if we add manually these hexa numbers, not decimal numbers, hexa numbers. We will get 96. If we add these numbers, you can get calculator online for hexa addition, or you can do it by yourself by learning how hexadecimal works. So these 5 element is equal to 96. You can do it by yourself. So but it didn't print 96, it printed this weird character. So why is that? So we will see what's on 96. We have 90 on ASCII value. We have the same character as is printed on the screen. So this means in ASCII we are having the exact answer, but we do not printed our ASCII value. Rather, we have printed the character which is equal to 96 in ASCII, which we will learn how to print 96 rather than the character which is equal to. So that's it. Thanks. If you have any question, any query, you can contact me. This is my email address, my Facebook page, and my phone number. Thanks.